Alright, so for this project, the purpose is to get our two cars to collide. So the first thing we need is we need a parametric equation that describes the path of our car as it leaves the table. So when we send our car down our ramp, it's important to make sure it always starts at the same point. So I have this labeled, or have a mark there. It's also important to make sure that our ramp setup doesn't change. So on my calculators here, sometimes some tape will help to hold things down in place so that they don't move from day to day. So when I release my car from here, I want to know what the instant velocity is going to be once it leaves my table. I'm only going to have an X direction velocity because when my car leaves the table, it's only going to be traveling in the X direction. So I'm going to send my car down the ramp, and I want to be able to calculate the initial velocity as it left the table. So to do that, we can measure the distance from the table horizontally to where it landed on the floor. Okay, so I've already done that for my car and my table setup. So on my sheet, I'm going to draw a picture of what was happening. We have our table, there's a ramp, my car is going to leave with some initial velocity. And that initial velocity is what we want to calculate. Okay, so I measured that my car landed 31.2 centimeters away. But I need to convert that into meters because my gravity, I know that gravity is negative 9.81 meters per second squared. And since gravity is measured in meters, I should measure my distances in meters as well. So this distance here is 0.312 meters to from the edge of the table to where it lands. Okay, and so I want to know what its initial velocity was. Okay, so based on that, we can figure it out. Here on this sheet, you're going to show all your calculations for all of the variables that we need for our parametric equations. Okay. The only thing is you need to add at the bottom. You need to add how you calculated what the time was. Okay. So remember, with our parametric equations, I'm going to write it over here. We have an X equation and a Y equation, and the standard is that it's going to be my initial X position plus my velocity initial in the X direction times time plus 1/2 acceleration in the X direction times time squared. And Y is the same thing, except we're only concerned about the Y direction. Okay. So I can already start filling in my table for some of the things that we know. We know that acceleration is 9.81 meters per second squared in the Y direction, because that's gravity. Okay. We also know, based on our setup, since my car is leaving flat, horizontal, that my initial velocity in the Y direction is 0 meters per second. Okay. Also from our setup, we know what our initial Y position is. My initial Y position is how tall my table is. And in this case, my table is 75.5 centimeters, so 0.755 meters. It's important to be as accurate as possible because we're going to try to make a collision happen, so we need to be as precise as possible. So in this case, my Y initial is 0.755 meters. Okay, and now what we want to do is we want to figure out our acceleration in the X direction, our velocity in the X direction, and our initial X position. Two of those are easy. The first one, the acceleration, is, in the x direction, is 0. Because an object that goes off the table is no longer, it's not accelerating, it's only accelerating downwards due to gravity. Okay, my velocity in the x direction I have to calculate. My initial x position, I'm going to make it 0 meters so that my life is easy. So if I make this 0 meters, then I know that my car is going to land at 0.312 meters. Okay, so now what we have to do is we have to calculate our velocity in the x direction. What we have is we have a distance, we have our distance, and so to calculate velocity, the only thing that we need now is a time. Okay, so remember that velocity is equal to our distance divided by time. And so we can plug in our distance, but we're still going to need to know our time. And our time is going to be the same time that it takes for the car to fall from the table to the floor. Okay? And that's why we had to add time down here. So we're going to find the time that it takes for our car to fall this vertical distance. Okay, and to do that, we're going to use our y equation right here. The y is equal to the y initial plus velocity in the y direction times time plus 1/2 at squared. So we plug in what we know. Our initial y position is 0.77, or excuse me, 0.055 plus the velocity in the y direction is 0. So this middle term is just going to cancel out, and then I just have to add in my acceleration, 1/2 times my acceleration. So 1/2 times negative 9.81 meters per second squared times time squared. Okay, and I want to know when my final position, y, is going to be equal to 0, because that's when the object has hit the ground. Okay, so I can solve this for t, and I'll leave the algebra up to you, but you should get 0.392 seconds. Okay, and I just double check my math. So I know that the time it takes to hit the ground is 0.392 seconds. So with that information, I can now calculate my velocity in the x direction. So my velocity in the x direction is going to be the distance that it traveled in the x direction divided by the time that it took. It takes the same amount of time that it took for the car to hit the ground. So my velocity is now 0.795 meters per second, and that's my velocity in the x direction.